are going to demonstrate how to determine the grain size distribution using a hydrometer test. In this experiment, we use 50 grams of soil which is prepared by the teaching assistant. Before we start, you can clearly see that there are two layers of soil. The white part is kaolinite and the darker part at the bottom is sand. This soil specimen was previously soaked for at least 16 hours in a 100 ml deflocculating agent which is with 4% concentration. We are going to shake this mixture at high speed using a mixer, transfer it to a suspension cylinder and take hydrometer readings. Throughout the test, it is important to ensure that we do not lose any of the soil particles. The mass must remain as 50 grams. Now we need to transfer the mixture from the beaker to the stirring cup of the mixer. There must be a lot of soil particles left at the bottom of the beaker. Hence, we need to use the distilled water to wash the beaker. Make sure that the cup is firmly fixed to the mixer. Also, check the water level in the stirring cup because it may spill if there is too much water. Switch on the mixer for 1 minute such that the soil particles can disperse. Now remove the stirring cup. There will be soil particles left on the stirrer of the mixer. Use the wash bottle to wash all the soil particles into the stirring cup. Now take a look at the calibration cylinder. It contains 1000 ml of deflocculating agent which is 0.4% in concentration. We need to measure the temperature because the temperature can affect the viscosity of the fluid. Next, we transfer the slurry into the graduated suspension cylinder. Wash the stirring cup such that all the particles will be washed into the cylinder. Add distilled water until the final volume is 1000 ml. Insert a suction bulb at the top. Mix the slurry thoroughly by turning the cylinder upside down and back repeatedly for 1 minute. The frequency is recommended to be half turn per second. After 1 minute of turning, place the graduated cylinder on a table. Remove the suction bulb. Place the hydrometer inside the suspension. The first hydrometer reading should be taken at 15 seconds after the turning stops. Additional readings should be taken at 30 seconds, 1 minute, 2 minutes, 5 minutes, etc. Based on the lab manual, the last reading should be taken at 150 minutes, but it should be noted that the ASTM guidelines recommend the last reading to be taken at 1440 minutes. Now suppose that we have taken the last hydrometer reading. We need to pour the slurry onto the number 200 sieve. The kaolinite will pass through the sieve easily. There are large particles remaining at the bottom of the graduated cylinder. Use a water pipe to wash the particles out of the cylinder. Transfer the large particles from the sieve to a container. Put this container into an oven which has a temperature of 110 degrees Celsius. Based on the ASTM guidelines, we need to keep the container with the large particles in the oven for at least 24 hours. Wear a glove when you place the container into the oven. These are the oven-dried large particles. Now we need to perform the sieve analysis to obtain the complete grain size distribution curve. Measure the mass of the container with dry soil. You should be able to determine the mass of the dry soil because you should have previously obtained the mass of the container. At the end of the sieve shaking, you will need to measure the mass of the dry soil on each sieve. When you add up the masses, the total should be equal to the mass of the dry soil in this original container. Make sure that the sieve order is correct. The top sieve should have the smallest number. Below the number 200 sieve is a container that collects the soil with size finer than the opening of the number 200 sieve. Pour the dry soil onto the top sieve. Cover with a lid. Then we can bring the stacked sieves to the shaker and shake for 15 minutes. This is the shaker. Place the stacked sieves inside it. At this point, there is a gap between the lid and the top cap of the shaker. So we need to adjust the shaker height such that the sieves are firmly fixed to the shaker. Switch on the shaker. Now we need to determine the mass of the dry soil remaining on each sieve. As an illustration, we take a particular sieve. Measure the mass of the sieve with dry soil. Zero the record. Use a brush to transfer the soil to a container. Then weigh the sieve again. The negative number here would be corresponding to the mass of the dry soil that has been transferred to the container. Repeat the same process for other sieves.